Hey guys, this tutorial is all about Java ThreadLocal and why we need Java ThreadLocal and what is the difference between Java ThreadLocal and Synchronized. So basically Java ThreadLocal is needed for maintaining static data that is required while that thread is executing. So there could be multiple threads running at a time and you might want uh, the static data that is required locally to a particular thread. In that case, you could use thread local, and the reason for using the thread local is the data is not residing in heap, it is residing in thread private stack. So basically, as soon as the thread dies, the thread local data also is gone, right? So many of you might think like we can use thread specific variables, but there are chances of accidentally sharing the data across the threads. So that's another reason why you should be using thread local. Thread local uses internal thread map. So I will show you the code, how it uses the internal thread map and how it stores the data that is local to that thread only. Alrighty, how ThreadLocal works, right? I talked about this. So basically, the data is stored in thread map, and for each thread, thread map is created. And I will show you how it is done. All right. So, what is the difference between thread local and synchronized, or which one should be used when, or are both same? Just there's some performance related difference. So basically, thread local and a thread local and a synchronized have different use cases. Thread local is to ensure data is not shared across the threads, while synchronized is to ensure that while the data is shared across the threads, it is accessed by only one thread at a time. Now, how this is done? So thread local basically ensures this by putting data in thread private stack so that as soon as thread dies, the data also dies. While in synchronized, data is put in heap and you use synchronized block when you want to share the data. I will show you an example now how you can use thread local and why exactly we need thread local, why we can't use normal variables, right? I could create n variables in the thread in n threads. So n variables in n threads should do the job, but there are still chances of accidentally being like this data being getting shared. So for that, thread local is used. So you can think of it like a design pattern as well, where you are just passing in the object thread local, and it's automatically ensuring to whatever threads you are passing it to, all the threads are having their own copy of data. Alright, I will show you example now. So here I have created this class ThreadLocal1. What I'm doing here is I have just created a ThreadLocal variable in which I am passing in integer as the generic type. You can create non-generic ThreadLocal as well, but I would always propose that you use generic ThreadLocal. So now here I have two threads, thread T1 and T2. T1 actually takes test class instance and T2 takes test1 class instance. What is test1 and test2? Let's see those. So test1 is basically, well, test is basically this. It's having a thread local variable and then it's a constructor for that. So basically test1 and test are same. The only difference is that I'm just putting in this different sleep here, right? And also I'm setting a different data. I'm just trying to show you that this 20 and 30 both are set on the same variable. This same variable, like you can see here, I have passed it in the constructor and I'm setting the value to 20 here for test and 30 here for test 1. So ideally, like if it's not thread local, you should see, you don't know which value you will see because it is not known when this will be executed, right? Though I have made my threads like this, that this executes after 2 seconds, right? And this executes this statement after 1 second. So let's run the code. Let's observe the output basically. Okay, so for thread 1, it is 30, right? That's what we set for thread 1. For thread 0, it's 20. That's what we set for thread 0. But the thread local instance I passed in is the same instance. I don't see a difference. So what is happening here? Let's see the set. See the set. Here you get the current thread T, right? And then your thread local basically gets the thread local map based on the thread. And if the map already is not existing, it sets the value. It's already existing basically, then it sets the value. Otherwise, it creates a new map and then sets the value. That's how it is doing it. So this thread local map is the key here, right? It's maintaining data for each thread. That's why it's called thread local, and that's how it works. So that's the basic example of why thread local, how thread local works. I can give you a quiz basically. So the quiz is what happens if I do this. What should be the output of these two threads? Should it be 20? Should it be 30? Or should it be 50? Or should it be 2030? Should it be 2050? Or should it be 3050? Or some error or what? Just think about it. You can pause and think about it. Well, here's this answer. So, you know that in Java, a main is also running inside a thread, right? So this thread local dot set actually worked on the main thread. But here in test 1 and test, you are not accessing main thread, right? You are inside test and test 1 threads, right? So you actually see 20 and 30. So the output remains same. 50 is for main thread and you are not printing anything from main thread. See, here it is, right? Now if I print, let's just do that actually. Let me copy it from here. Let's run it again. I'm just trying to show you with another example how thread local works. Now it will print it will print 50 here basically. Alrighty. Hope you understood how thread local works, why we need thread local. So it's, you can say, kind of a design pattern if you want to, and how it is different from synchronized. While synchronized ensures that you are sharing data securely, thread local ensures you are not sharing data securely. It is ensuring that to the 100%. Alright, thanks guys, and please don't forget to subscribe our channel